This video provides a detailed introduction to the HDR function of time-of-flight ToF cameras. First, let's look at why we need HDR. In complex environments, a ToF camera often needs to measure both highly reflective and low reflective objects simultaneously. If a fixed long exposure time is used, highly reflective surfaces may cause overexposed regions. On the other hand, reducing the exposure time may result in missing point cloud data for low reflective objects, limiting the camera's application. Fortunately, HDR function effectively addresses these challenges. In simple terms, HDR imaging solves the coexistence problem of high and low reflective objects within the same scene. The principle of HDR can be summarized in 2 points. Firstly, long exposure captures details in dark areas, preventing incomplete imaging of low reflective regions. Secondly, short exposure preserves highlights, ensuring accurate imaging of bright or highly reflective areas. Now, let's take the Vzense DS camera as an example to demonstrate HDR performance. As shown, enabling HDR results in the best imaging quality. When HDR is disabled, multiple point cloud losses can be seen on the tire and rim. While HDR significantly improves imaging quality, it also has some drawbacks. First, since frames with different exposure times need to be fused, frame rate decreases and latency increases. Second, due to the principle of ToF technology, distance accuracy may vary at different exposure times. For example, precision may decrease at short exposures, sometimes causing layering effects on flat surfaces. Therefore, in practical applications, it is generally recommended not to enable HDR. Instead, optimal results can usually be achieved by adjusting frame rate and exposure time. Thank you for watching. See you next time.